Hello, welcome to Brunei Math Club. In this video, we study upper triangular, lower triangular, and diagonal matrices. Okay, let's start. Let's start with the upper triangular matrix. A matrix, a square matrix, n by n matrix is called upper triangular matrix if its ij element is 0 when I is greater than j. What this means is that if we have a matrix like this, square matrix, then below the diagonal, all the elements are 0. And above the diagonal, there may be some non-zero elements. For example, let's consider a 3 by 3 matrix. So 1, 2, 3, 0, 5, 6, 0, 0, 9. So this is an upper triangular matrix because these elements below the diagonal are all 0. In a similar manner, we define the lower triangular matrix. A matrix is called lower triangular matrix if its ij element is 0 when I is less than j. So that means all the elements above the diagonal are all 0. And the elements on the diagonal or below the diagonal may contain some non-zero elements. And you can say a matrix is a lower triangular matrix if its transpose is an upper triangular matrix. For example, the transpose of this matrix. Let's take a transpose. Then we have 1, 2, 3, 0, 5, 6, 0, 0, 9. So this is a lower triangular matrix because the lower triangle contains non-zero elements, and above the diagonal they are all zeros. We define the diagonal matrix. A diagonal matrix is a matrix whose ij elements are all 0 if I is not equal to j. That means only the diagonal elements may be non-zero and all other elements that are off diagonal are zeros. For example, the identity matrix is a diagonal matrix, as is this one or this one, and so on. You can also say that a diagonal matrix is both upper triangular and lower triangular at the same time. For triangular matrices, we have the following notable property. Suppose A and B are both upper triangular matrices. Then their product, AB, is also upper triangular. Let's show this. So since A and B are upper triangular, we have Aij equals to 0, Bij equals to 0 if I is greater than j. What we want to show is that the ij element of their product is equal to 0 if I is greater than j. So let's assume this I is greater than j. Okay, then Abij is equal to k aik times bkj. Remember this, I is greater than j. Now let's split this sum into two parts. One, k is less than I, and the one with k greater than or equal to I. Of course, this k runs from 1 to some number, say n. Now, for this part, I is greater than k, so I is greater than k, so this part is 0. And for this part, k is greater than I, but we are assuming I is greater than j. So that means k is greater than j, right? So k is greater than j. The first index is greater than the second index. So that means this part is equal to 0 because these matrices are upper triangular. Therefore, this is 0 plus 0 equals to 0. Therefore, the lower uh, triangle of the matrix is all 0. Therefore, AB is upper triangular. Okay, that's it. By a similar argument, we can say that the product of two lower triangular matrices is also lower triangular. And also, since diagonal matrix is both upper triangular and lower triangular at the same time, so the product between two diagonal matrices are also diagonal. That's all for this video. See you later. Bye. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.